This video is about Chapter 2, the origin and evolution of Earth. In this chapter, we will read about the story of the origin, that is the formation of Earth, and evolution, that is how Earth evolved over time, meaning what were the physical changes that the Earth went through. Now, the origin of Earth has two theories, basically the early and modern theories. I've made separate videos on both the theories. I'll be posting the link in the description, as well as you can click on the link here on the screen. So watch that video and you will understand these theories well. The expansion of universe means increase in space between the galaxies. Always remember this order. A universe consists of more than one galaxy, and one galaxy consists of moons, asteroids, planets, and stars. So the solar system that we are part of is one galaxy. Like that, there are many other galaxies. And the name of a galaxy is Milky Way. Though we know there are many other galaxies, but we do not know whether there is another universe. So the scientific community only believes in the theory that the universe is expanding. Now we will read about how the stars were formed. Now the formation of stars is believed to have taken place some 5 to 6 billion years ago. Earth is believed to be 4.6 billion years old, so clearly stars were there before the planets. Previously, we spoke about how matter and energy were scattered in the universe due to the big explosion of the singular atom. One thing to know is that the matter and energy were uneven, meaning there were differences in the densities in every matter. Because of that, there was attraction between these matters, and that's how hydrogen and helium atoms were formed. Basically, hydrogen and helium are a gas. Like this, there are many tiny groups of hydrogen and helium gases constantly colliding with each other and producing energy. This process is also called as fusion reaction, where two light nuclei combine together, releasing vast amount of energy. And this energy gave rise to formation of stars. Let's quickly understand how to measure a light year. Again, I've made a separate video on this topic as well. The link is there in the description. You can also click on the annotation on the screen, so follow the link and watch the video. Now we are going to talk about the formation of planets. Now there are again some stages in the development of planets as well, so let's go through them. So just moments back, we have read that stars are localized lump of gases. Now the gravitational force within those lump leads to the formation of a core, to the gas cloud, and a huge rotating disk of gas and dust envelopes around the gas core. So let me just show it to you with the help of an illustration, because it's very difficult to make you understand with words. So a good example to illustrate this is, take a bucket of water, a little water, not much, and put some sand in it. Now spin the water in that bucket in a circular fashion. Soon you will notice that all the mud particle that you had poured, it will come in the center and gather. So that's how it forms a core. And the same thing happens in these gas clouds inside a star. And then after a long time, layers of layers starts forming, and that's how a rotating disk of gas is formed. And then in the next stage, the gas cloud starts getting condensed, meaning it gets very concentrated. And due to this phenomena, the matters that are around the core develops into small rounded objects. Then again, after time, what happens, these small objects, by the process of cohesion, meaning they form group sort of a thing, and develops into what is called planetesimals. So you see, most of the things happen because of collision and gravitational attraction. Because of these phenomena, the materials stick together, and that's what makes these large number of small bodies. Now in the final stage, these large number of small bodies, they accrete to form a few larger bodies. So the meaning of accrete is forming layer after layer. So these smaller bodies that were formed due to collision and gravitational attraction, with time what happens is several layers are formed on it. As a result, from a small body, it becomes a large body. And that's how planets are formed. I hope you understood somewhat how the planets are formed. If at all you did not follow up, I recommend that you go back a little bit and watch it again, because it can get difficult to explain by using these words that are given in the book. So I'm trying my best to use illustrations and examples and, refining the words into simpler terms. So just go back a little bit and watch it again, and I'm sure you'll get it. Now we're going to read about our solar system. So here it says our solar system consists of 9 planets. Now this is a fairly old book. So as of now, there are 8 planets in the solar system. So that means Pluto is no longer a planet. And the reason behind that is because it has been classified as dwarf. So the meaning of dwarf planet is, it is a round mass of metal and rock or gas moving around the sun that is not large enough to be considered as a planet. Okay, some of the dwarf planets in our solar system includes Pluto, then we have Ceres and Eris. So as I've told you before that everything right from planets and stars and everything has been formed out of this cloud called nebula. So the core formation of this nebula started somewhat around 5 to 5.6 billion years ago, and the planets were formed about 4.6 billion years ago. So clearly it means that stars were there before planets. Now don't forget this, just remember this. Our solar system consists of Sun, that is the star, Sun is a star basically, and then we have 8 planets, then 63 moons, then millions of smaller bodies like asteroids and comets, and huge quantity of dust, grains and gases. And if you see, it is because of these two last terms, that is dust, grains and gases, there are new stars and planets that are coming up. So there's always a new discovery by NASA about all these planets and stars. So out of the 8 planets, Mercury, Venus, Earth and Mars are called as the inner planet. So if you look at the solar system, after Mars, the Jupiter planet comes, and in between Mars and Jupiter there is a big asteroid belt. So those planets which are out of asteroid belt, including Jupiter, they are known as outer planets, and those which are inside, they are called inner planets. So these planets which are inside the asteroid belt, they are called as terrestrial planets, meaning they have Earth-like similarities. In other words, they consist of rock and metals. And the planets that are outside the asteroid belt, they are called Jovian or gas giant planets. So basically they are like Jupiter, and they are huge planets, but they have very thick atmosphere, mostly of helium and hydrogen. And this is another cool fact. All the planets were formed in the same period, sometime about 4.6 billion years ago. So when we hear something like this, that all the planets were formed in the same period, it clearly proves the fact that whatever phenomena that caused these planets to exist is actually true, which is the Big Bang theory, the universe being expanding Wala theory. Because just for argument's sake, had it been the fact that all the planets came into existence at their own time, then it would be difficult to argue that what actually happened, because there's going to be very different kind of data, something happened because of something else, and then something happened because of something else. If everything happens because of one reason, then it is easier to study and understand. I hope you're getting what I'm trying to say. Now let's try to understand what is the difference between terrestrial and Jovian planets. So let me quickly tell you this. Terrestrial planets are those planets which are in between the Sun and the asteroid belt. And the ones that are outside the asteroid belt, they are known as Jovian planets or outer planets. So as we know that most of the terrestrial planets are full of rock and metal. So that means it has very less gas and dust. And if you look at the Jovian planets, they have a lot of gas present, dust and gas present. So the theory goes like this. Newton realized that the reason the planets orbit around the Sun is related to why objects fall to Earth when we drop them. The Sun's gravity pulls on the planets, just as Earth's gravity pulls down anything that is not held up by some other force and keeps you and me on the ground. So heavier the objects produce a bigger gravitational pull than lighter ones. So as the heavyweight in our solar system, the Sun is the strongest gravitational pull. Now with this theory, you know that the terrestrial planets which are between the Sun and asteroid belt, they are nearer to the Sun. And because of that, they exert a lot of gravitational pull. And because they are nearer to the Sun, meaning the heat of the Sun blew away all the gases and dust. But then the Jovian planets which are outside the asteroid belt, they are far away from the Sun. So the solar winds were not that intense. That's why these planets still have a lot of gas and dust particles. So that's the reason between the inner planets and the outer planets, or in other words, the terrestrial planets and the Jovian planets. Now we're going to talk about the Moon. Moon is the only natural satellite of the Earth, meaning Moon just revolves around the Earth. Now there is a theory behind how the Moon was formed. So if you see, a lot of the time we are reading about theories in this chapter. So this chapter is full of theories. So let's understand the theory behind the Moon as well. So in 1838, Sir George Darwin, he suggested that the Earth and the Moon, they were combined. Okay, they were joined together like a dumbbell shaped. So if you've seen a dumbbell, it looks like this. Now what happened was it eventually broke, and the material that was forming the Moon, it got separated from the Earth. And to support this theory, Darwin went on to say that if you look at the depression in the Pacific Ocean, so Pacific Ocean is the largest ocean and the deepest ocean. So the depression that occupies the Pacific Ocean, that depression is due to the separation of the moon object from the Earth. So this is the theory of George Darwin. Now the present scientists, they do not accept this theory. What we now believe is that the formation of moon as a satellite of Earth is an outcome of giant impact. Now this theory has another name which is called the Big Splat. Now Big Splat means big splash, a giant impact. Now what this theory says is there was an object of the size of Mars. So that object, that body, it collided into the Earth sometime shortly after the Earth was formed. So when two objects collide, there are these debris. So these portions of small blasted material, they continue to orbit around the Earth. And due to gravitational attraction and collision, these small particles eventually formed into the present moon. So this theory is now widely accepted about the origin of moon. Now we're going to read about the evolution of the Earth. So once upon a time, the planet Earth was a barren, rocky and hot object with a thin atmosphere of hydrogen and helium. And today when we see a picture of the Earth, it does not look like that. So obviously there must have been some events, some processes which has caused this change. So let's go ahead and understand what led to the evolution of life on the surface of the planet. So we know that all the celestial body were formed with a process called accretion, meaning a layer after layer after layer. That's how they became from small body to a large body. Similarly, Earth is no different. The Earth has a layered structure. So from the outermost end of the atmosphere to the center of the Earth, the material that exists is not uniform, meaning they are not same. So right from the outside of the Earth, as we go towards the interior of the Earth, the density increases. That's why we also know that there are 5 layers in atmosphere. And then we also know that the Earth's interior is divided into 4 parts. That is the crust, mantle, outer core and inner core. And that's why in geography we also have different disciplines to understand the Earth. We have the lithosphere, then we have the study of atmosphere, hydrosphere. So they have been nicely categorized in different subjects so that we can read about Earth in a much more better sense. Now we are going to read about lithosphere. When we hear the word lithosphere, it means the outer layer of the Earth consisting of crust and mantle. So initially the Earth was in a volatile state, meaning there was constant change taking place. Everything was going through rapid change, so all the particles that were involved in the creation of Earth, their densities were increasing as well. There was so much collision taking place and energy was increasing. As a result, temperature was also increasing rapidly. In chemistry, if you want to extract or refine any metal, you need to put the metal in a furnace where the temperature is extremely high. The idea is to turn the metal into a molten state so that the properties of the metal get separated. Similar thing happened here as well. When the temperature was so high, all the materials started getting separated depending on their densities. Heavy materials like iron started sinking towards the center of the Earth, forming the core, and the lighter ones moved towards the surface. With time, the temperature cooled, and the outer layer in the form of a crust was formed. And then there was another big impact, that is the creation of moon, which we also call the giant impact. Even that further heated the Earth, and that's how materials got separated into different layers. We know Earth has 4 layers like the crust, mantle, outer core and inner core. Always remember, from the crust to the core, the density of the material increases. In the coming chapters, we will discuss about the properties of each of the Earth's layer. Now we are going to read about the evolution of atmosphere and hydrosphere. So in the Earth's atmosphere, you will mostly find nitrogen and oxygen. Nitrogen consists of some 78% of the entire air and 20% or 21% is oxygen. There is a separate chapter, that is chapter 8, which deals with the composition and structure of Earth's atmosphere. So we will read in depth about all these things in that chapter. So there are 3 stages in the evolution of the present atmosphere. It is because of these 3 stages the present atmosphere came into being. So in the primordial atmosphere, the Sun and its planets formed about 5 billion years ago, where there was an explosion of a supernova, which is a big star. So that before bursting had generated heavy elements starting from hydrogen and helium. So that was the first stage of the present atmosphere. I mean to say, atmosphere initially looked like that. And then comes the second stage. We have read that the Earth was a very volatile object. there were constant changes, rapid development was going on. And the temperature was so high that the interior of the earth was super hot. So when an object is super hot, it will emit heat, which is also called as thermal radiation. So we have to say that these thermal radiation, they will also contribute to the evolution of the atmosphere. So every single aspect together contributed towards present atmosphere. That's why we have to count every single thing. And now comes the final stage, that is the third stage. Today, when human beings and living organism came into existence in this world, there was a process called photosynthesis. So photosynthesis is a chemical process through which plants, some bacteria and algae produce glucose and oxygen from carbon dioxide and water, using only light as a source of energy. Before even humans arrived on this planet, there were trees, plants and all sorts of grasses and etc. So we can say that the process of photosynthesis has already begun before the humans arrived. And we know that plants take carbon dioxide and emits oxygen. So again, there is a emission of oxygen involved. And that is the final and the third stage of the composition of present atmosphere. Always remember the primordial atmosphere, which is the initial atmosphere when the earth was beginning to form. That atmosphere consisted only of hydrogen and helium. So that atmosphere went away, and the reason behind that is because it is not just earth, all the terrestrial planets. So we have spoken about what the terrestrial planets are. These are the planets that are in between Sun and the asteroid belt. So basically there are only 4 planets: Mercury, Venus, Earth and Mars. Now these planets, the terrestrial planets, since they are closer to the Sun, these planets received a lot of solar wind coming from the Sun. It stripped off the hydrogen and helium atmosphere. And that's why these planets don't look like the jovial planets, the planets which are outside the asteroid belt. And finally, when the Earth was cooling down, the gases and the water vapor, they were released from the interior of Earth. Now this thing is very easy to imagine. Whenever you're trying to boil water in an utensil at your place, you will see that if you put a cover on it, or if you put some kind of a plate on it, you will see that the plate will gather all the water vapor. So the similar thing happened when the Earth was cooling down, all the heat was released upward, and in the atmosphere, the water vapor was collected. And that is how the present atmosphere started. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little of free oxygen. So the process through which the gases were outpoured from the interior is called degassing. Now you must be wondering that, okay, the gases were degassed, so how did it still continue to form water vapor? And the answer to that question is the continuous volcanic eruption. So volcanoes are like a ventilator of the earth. So from these ventilators, the inner core, the heated substance of the earth, starts pouring out. And again, if there is a substance which has a high temperature, there will be heat. And because of this continuous volcanic eruption, there was a lot of water vapor and gases generated. And as these water vapor were released, they started getting condensed. And then the carbon dioxide in the atmosphere got dissolved in rainwater, and the temperature further decreased, causing more condensation and rain. And then once rain started happening, the rainwater falling onto the surface got collected in the depression to give rise to oceans. And that's how the ocean bodies of the earth were formed. So these Earth's ocean were formed within 500 million years from the formation of the earth. Now that tells us that the oceans are as old as 4,000 million years. And then once the oceans were formed, life began to evolve. And if you notice, bacteria were among the first life forms to appear on Earth. And if you see, humidity is perfect for any bacterial growth. And humidity is formed due to heat and water. Hence, it is obvious that once the oceans were formed, quickly life began to evolve. And once life began to evolve, the process of photosynthesis also started. So for a very long time, life was confined to the oceans. That means there was no presence of life on a landform. It was only confined to ocean. Because ocean had the perfect combination of oxygen through the process of photosynthesis. And eventually this big ocean was saturated with oxygen. And after that, oxygen began to flood to the atmosphere. And that's how oxygen content started increasing in the atmosphere. Now comes the last topic of this chapter, the origin of life. Because once the earth was formed, it is necessary to know about the life on earth. Otherwise, the entire big picture is incomplete. That's why the origin and evolution of life is regarded as the last phase in the evolution of earth. So far, after reading all of this, we are clear about the fact that initially it was impossible to live on Earth because the conditions were not ideal. Earth was volatile, it was super hot, there was very little oxygen, so all these things were going on. Hence, the modern scientists, they think that the origin of life is due to the complex chemical reaction that generated complex organic molecules, and because of their assembly, we came into present. And this assembly of complex organic molecules is such that it duplicates themselves. It is just like amoeba, how it splits into two equal copies of itself. Similarly, this organic molecule, it started copying itself, and that got converted into inanimate matter, and that converted some matters which were lifeless, which had no sign of life, into living organism. So when you look at a rock, you'll find fossils in it. Fossils are the dead decay of animals and plant organism. Hence, when we look at a rock, the record of life that existed on this planet can be seen across different periods. So when you look at blue algae, which is found in lakes and water bodies, and if you look at the microscopic structure closely, you will find that these formations are present in rocks that are much older and are some 300,000 million years ago. And that is how we can assume that life began to evolve sometime 3,800 million years ago. And if you want to know how a unicellular bacteria turned into a modern man, then you have to look at this geological time scale. So this geological time scale shows some life major events. And it is very fascinating to see how this thing happened. It is almost like a magic, but there's a huge, deep science involved. And that is why it makes geography interesting. I'm so fascinated to read all of this. Maybe I will make a separate short videos on these smaller concepts as to how human came into existence, how Earth was formed, how this ocean were formed, moon were formed, etc. Anyways, with this, we have come to an end of this chapter. And this chapter has been a real eye-opener till now for me. And it's so interesting and fascinating to read this. I hope you understood whatever that I told you. Though in between it was kind of difficult for me to comprehend because the words that were used, they were not very simple to be able to convert them into a real metaphor or a simpler example. I hope you found this video informative and let me know what you think about this. So as usual, question answers can be found on the website. So thanks for watching and I'll see you in the next one. If you enjoyed these videos and see a purpose behind watching them, please like the video and comment down below. Until then, catch you guys later and talk to you guys on the next one. Peace.